In this problem, 6 charges are placed at the vertices of regular hexagon as shown in the figure. The electric field on the line passing through O and perpendicular to the plane of the figure at a distance x, which is very much greater than A, from O is. See here, regular hexagon. So all the sides are equal. So these are the sides. And also angle 60 degrees here. All angles are 60 degrees. So like this. And also this distance are inside. They are also equal. So 6, 1, 2, 3, 4, 5, 6 equilateral triangles also formed. This is regular hexagon. So in regular hexagon, 90 degrees to the plane of the hexagon means from here to, from some height, from this height, from here to above some x distance, we have to calculate the electric field. So let us calculate. Take, this is regular hexagon. This is plus q, this is minus q, this is plus q, this is minus q, this is plus q, and this is minus q. This is a center O. From the center at distance x, here we have to find the, at point P, the electric field we have to find. So let us find the first electric field value because of two charges. This is plus q, this is minus q. In between O is there here, O, this line I have taken, O is there. So from O, this is the x distance. So at x distance, we have to find the electric field. So these angles we don't know. So let me say these are alpha angles. So this plus q here at point P, this point P is here, this is x distance. So here this is the electric field direction. I may say this is E naught, and due to minus q, this is the direction of electric field. Both the electric fields are simultaneously acting at P. So this is the direction of resultant electric field E. This is also alpha, this is also alpha. Then this is here E naught. So horizontal component, vertical component cancel each other. Only horizontal components will be there. So horizontal component of this E naught cos alpha. This is also E naught cos alpha. So 2 E naught cos alpha. This value let us calculate first. That is equal to 2 E naught value. See, this is A, this is A, this is center here. This is A, this is A. And in the middle towards us, this is X. Right, I cannot draw upwards, that's why I drawn here. So this is not 60 degrees. This is this is the surface. From the surface at x the distance I am talking. So here it is alpha. This is A, this is x. So this is root of x square plus A square. Right. 2 into E naught value. E naught value how much? K. This is Q by root of x square plus A square whole square is equal to x square plus A square into cos alpha, right? So that is equal to, this is the resultant electric field due to single this line. I am from plus q to minus q. Here I am talking for this line. Normally at x distance I am calculating the electric field. So E is equal to how much? This is the direction of electric field. Parallel to the, see, if I take x distance parallel to this line, one electric field will be there. That electric field I am calculating. 2kq by x square plus a square into cos alpha. This is the alpha. This is right angle triangle. Cos alpha. Adjacent side by hypotenuse. Adjacent side is a, hypotenuse is x root of x square plus a square. So adjacent side by hypotenuse, root of x square plus a square. I will write root as 1 by 2. Then I will get the E value acting at P due to this line is 2kqa by x square plus a square whole power 3 by 2. So this is E value, equation 1. Now let us visit back the diagram. This is the regular hexagon, what we are talking about. This is plus q, this is minus q, this is plus q, this is minus q, this is plus q, this is minus q. Here, this is one line, this is one line, this is another. All are meeting at O. At O, 90 degrees to the perpendicular to this surface of this regular hexagon at x distance. So I will write like this. At x distance means I will draw like this. At x distance. What is the direction of E here? Parallel to this line, right? This line to this line. This is parallel. What is the value? E. If I take this line q dash, x same E only, because the q and q, these values not change, so same E value will come, but that E value direction will be parallel to this one, from plus to minus. Electric field direction is from plus to minus, so same. So parallelly I will write this is E. This is due to this line. This line is also there, plus q to minus q. So this is another E. So this resultant of these 3E we have to calculate. That is the problem. Here 60 is there, so this is also 60 degrees. And this is also 60 degrees. This is the point P. At point P, that net electric field we have to calculate. Net electric field at point P, which is perpendicular to the plane of the regular hexagon. See, here E is there. Between this E and this E, 3 E's are there. Between these two extreme E's, angle is 60 plus 60, 120. So what we know from vectors lesson, if P is equal to Q and theta is equal to 120 degrees, then R is equal to P. So here this is E, this is E, angle between these two E's are 120, so resultant is also E. So because of these two, another E will come here. This is the resultant of these two. This E already there because of this line, that is the parallel. So EP is equal to 2E. That is the answer. Resultant electric field at P, which is perpendicular to the plane of the regular hexagon. This E value already we have derived. So this value I will substitute here. 2 into E value, 2kq a by x square plus a square whole power 3 by 2. Now let us apply the condition. This is since equation 1. Now what the problem is saying that x is very much greater than a. That's why a value is very small. That means a square we can neglect. So if a square I neglect, this equation becomes like this. How much? That is equal to 2 2s are 4, k QA by x is very much greater. So a square we can neglect. So x square 2 will come. 2 and 2 will cancel. This becomes x cube. So this is electric field at P. Further I will simplify like this. For K value 1 by 4 pi epsilon naught. Here Q A small a by x cube. So EP is equal to how much we got here? 4 cancels. QA will be there by pi epsilon naught. This x cube will also be there. So this is a resultant electric field perpendicular to the plane of the regular hexagon. So let us check which option is correct. QA by pi epsilon naught x cube. So second option is the correct option.